Okay, so writing the domain of a function when you don't have a picture is fairly easy. There's only two instances where we sort of restrict the domain. And that is when we have a square root or any even indexed function, because you can't have a negative under the radical sign because it won't be real. So that's one thing we're not allowed to do. And the only other thing you're not allowed to do in math is you are not allowed to divide by 0. So anytime you have a variable in the denominator, you need to make sure that you exclude any values that would make the denominator equal 0. So aside from those two things, you're pretty much going to have all real numbers. So since we're dealing with radicals, here's our problem. We need to make sure that we take the radicand, that's the thing under the square root sign, and we say that it is going to be greater than or equal to 0, because 0 is the smallest radical that we could take. As soon as we go below 0, as soon as we go into the world of negatives, we wouldn't have a real number answer. So a lot of the times you can just see what the answer is. You would say, well, what would it take to make my radicand equal 0? And that's kind of your starting point. So a lot of us can see that 0 is going to be the answer to that question. But we can also do it by solving. So let's solve this equation, the inequality, and we're going to get x is greater than or equal to 0. So the domain of this function is 0 and all numbers larger. You can write it like that, or you could say it's 0 to infinity. Now, with the second one, I think a lot of you, if you asked yourself, well, what would it take to make this equal 0? You would answer -6. So basically, -6 is your starting point. Your domain is from -6 forever and ever to infinity. So let's do it by solving, though. You write your radicand greater than or equal to 0, and then you just solve. Let's subtract 6, and we're going to get that x is greater than or equal to -6. So again, you can write it in its inequality form, or you could say we're going to start at -6, and we're going to go forever to infinity. So try the next few, and we're going to now check out how can you do domain and range when you have a picture. And finally, how do we tell what's going on when we have a picture? So given our picture here, the red function is a cubic function, a cube root function, and so you can see that it's going to go forever and ever to the left and forever and ever to the right. So the domain is all real numbers. There's no x it can't pick up. And it is slowly but surely growing down and growing up. And even though it's growing slowly, that doesn't mean that it isn't going to reach all of those y values. So the range is also all real numbers. So when it's got an arrow on both ends like that, that's really kind of all real numbers for both of them. The one that we want to look at is this. Anything that's even indexed has a definite beginning and end. So if we take a look at this picture, the only place that this exists is on this side. These x values are being included. So we can just look at it and say that x is in between. It goes to -infinity, and it's going to go all the way up to and include 0. So you can write it as an inequality. X is less than or equal to 0. Or you could write it in its interval form if you like that. Remember, you can't contain infinity, so let me get rid of that bracket. And we're going to do -infinity to 0, which it does include. So how does the range play out? Well, let's take a look. We've got a y. Let's put it in between two things. When we look at our y values, well, where does this thing even start? Well, it starts right here, and it goes forever and ever. Even though it's growing very slowly, it will go forever and ever upwards. So let's write what's going on there. We are starting as low as 3. We actually get to include it. And then it goes forever to positive infinity. So you could just say y is greater than or equal to 3 if you wanted. Or you could do the interval form where you include the 3, use the bracket, and you go to infinity, a parentheses.